Hey, y'all. Just give me a couple minutes to set up and we'll get this show on the road. Okay, can y'all raise your hands if you can hear me? Okay, very good, perfect. Okay, so let's get the show on the road today. I'm not streaming video just because I want to use the bandwidth for streaming the screen instead. Today, I want to talk about, go through a example question that I actually had on an exam a few years ago on entity relationship design. And it should also help you with the homework assignment. So I found if I don't go over it, it really tends to be difficult for y'all to figure out how to do things on both the exam and the homework assignment. It's just, it takes some time to get used to how to do stuff with ER diagrams. Let's see. Before I go into it though, I did want to say a couple things about homework 1. First of all, on homework 1, I know some of you are not going to be happy that you had a complete deduction on one or more of the questions for hard coding the hotel number for the Grosvenor Hotel rather than having your query ask for the string, the Grosvenor Hotel. But the problem is, if you hard coded the number, you completely destroyed the purpose of the problem, which was to show me that you knew how to use a join or that you knew how to use a where statement. So it didn't, the question didn't ask you for the, for hotel number 1, it asked, or hotel number 3, it asked you for ones at the Grosvenor Hotel. And the problem is that number can change. So you should never be hard coding that kind of information because it can change. And so I know it may seem harsh, but I'm not going to change those grades of 0 because A, you didn't write the query, you didn't show me you knew what I was trying to test you on for that problem. You defeated the purpose of the problem by, in effect, looking at the database and saying, oh, I now know the number of the Grosvenor Hotel is 1 or 2 or 3, so I'll just hard code it. And therefore, you didn't do what I wanted you to do. So just please, in nothing should you be in the habit of hard coding numbers like that, whether it's in a program at this point or whether in general, it's just you don't want to hard code things. It's you declare them as constants or the like. So at any rate, that's my take on that. The second thing is a number of you on problem 6 came close, but had 3 points deducted for the following issues. So you were asked on problem 6 to give a sum of all the prices at currently occupied rooms in the Grosvenor Hotel. So I'm not here, I don't have the complete query because I don't want to show, I want to show you where some of you went wrong with the result. So what I have here is the way that it should be done, which is you need to get all bookings where the date is less than or equal to the current date and the date too is greater than the current date. So that gives you right here, this gives you all bookings where the room is currently occupied. And then, and hotel name equals Grosvenor Hotel gives you all rooms or all bookings that are at the Grosvenor Hotel. So then what you just have to do is you have to, once you have the correct bookings, you have to then get the rooms they're associated with in order to get their price. And you also have to join that with the hotel in order to ensure that that room is in the Grosvenor Hotel. So you could do this with natural joins, which is actually the safest thing to do, and it gives you the right answer. Now, what happened is many of you used equalities, which is fine, but I'm going to show you what went wrong. So many of you did a join of the booking with the room, but you only did it on the room. So you said on B dot room number equals R dot room number. And you forgot that there was a, let's see, just a second. Select from natural join. Got that wrong. Wrong place. It's over here that went wrong. Many of you joined booking with room, but you only used one of the two common attributes, which was room number. And you forgot that there was also a hotel number. And what you end up with, let's see if we can, whoops. Got an error. Make sure that, I think the quotes have funky syntax. Yep, okay. That's the other thing. When you submit your queries, make sure that you're not copying them directly from Microsoft Word, because the quotes, the single quotes used in Microsoft Word aren't the same Unicode or ASCII symbol that are used by the MySQL interpreter. So what was happening here was it looked right, but I was getting a syntax error message. And the reason was because I actually did copy this out of my Microsoft Word things and solutions, and these two quotes were Microsoft Word quotes. And so I had to actually go back and change them so that they were the quotes that you see on the keyboard to get the right answer. Okay, so here, that's just the information from the booking relation. So now what I'm going to do is get it from the booking and the room. Let's see here. See if this is what I want. Yes, but it's somewhat hard to see. So what I'm going to do, sorry, it's hard to see. So I'm going to show you the result that Bhaskar sent me, because that's probably the easiest way to see it. And I need to find the, there we go. Okay. So here's the result of the second join that I showed you that's missing a join on the hotel number. What happens, I'm not sure I can really make this a whole lot bigger. I'll try. There's a little bit bigger. So you'll see that when you print it out, there's this extra booking in here for $135.50 in room 300. And you'll see that when I print out both the room and the hotel booking information, it's selecting room 300 from Hotel 44, which indeed is the Grosvenor Hotel in our test data. But the problem was in the booking relation, room 300, that actual reservation was associated with Hotel 15 and not Hotel 44. So the problem was when you did not do a kind of a double join, a join on both the room number and the hotel number, what you did is you found rooms that weren't only in the Grosvenor Hotel, but you found rooms that were currently occupied in other hotels as well. In this case, room 300 was occupied in hotel number 15. And so you included that in your result, even though that wasn't a reservation at the Grosvenor Hotel. So that's why you had 3 points deducted, because there were two common columns in the room and the booking relation, the hotel number and the room number, and you were only checking one of them. So you had to, or alternatively, you had to do that when you were also going into the hotel relation. You had to make sure also, no, with the room, sorry, with the room relation, let me come back here and just describe booking, describe rooms. Okay, so you see there's two overlapping columns here, room number, hotel number, room number, hotel number, room number. So you have to do a join on both of those. And then if you look at hotel, actually it just has hotel number, so there's only one common column there. So again, natural join is the safest thing to use because it automatically joins on all columns, and that's almost always what you want, is to join on all common columns. So the safest thing you can do when you're doing your joins is to use natural join. I have no problem with your using equalities, and I know I used equalities on my homework solution, but that's actually before I learned how valuable natural join was. So any questions about that or other things on homework 1? Okay. In that case, let's move on and move into the case study for today. So I'm going to assume that you looked at it. I know you may not have, in which case you better look at it quickly while I'm talking about it. And what I'm going to do is show you kind of what you should be thinking about as you read through a problem in order to identify what should be an entity, what should be a relationship, and what should be an attribute. So that's actually the key. The 3 key issues are, you want to know, when you're looking at a problem description, what you want to do is you want to identify what are the entities, what are the relationships, and what are the attributes, because those are the 3 big elements of the ER diagrams. So you're trying to figure out what is what. Okay, so as you're reading through it, that's what you should be kind of thinking to yourself is, what is each sentence telling me? So we come through and we read, and it says, we have an investment firm. The firm has a number of offices, and here's the first trap. So many of you are going to want to say that a firm is an entity. It's not. It is what we are creating the database for. So in fact, firm is not an entity here. And if you think further about it, an entity is going to end up as a relation in your database. So what exactly would the relation firm consist of? I guess maybe one tuple. It doesn't have information associated with it. So this is the first common thing that I see on homework assignments and exams is, I will say the hospital has, or the firm has, or the library has, and I see an entity for firm or hospital or library, and it's not an entity. It might be the name of the database, but it is not an entity. So we start out, the firm has a number of offices. Now that sounds more promising. This sounds like an entity, has a number of offices. Each office has a number of investment advisors. That also sounds promising, as though it might be an entity. Who service investors. Sounds like another entity, because that's physical. Investors own stocks that pay dividends. Okay, now dividends, turns out, is more like an attribute rather than a entity. So we'll get back to that, but this is really an attribute. Okay, it's an attribute of a stock. It's associated with a stock, and we'll see in a moment a little bit more about that. Now, there's something else about this first sentence. It has a number of verbs in it. So each office has, that's a verb. It suggests a relationship between an office and investment advisors. Who service, that's a verb. Sounds like another relationship. Investors own stocks. That sounds like another relationship. So when you end up with noun, verb, noun, so when you end up with noun, verb, noun sentences involving 2 or more entities, that is probably describing a relationship. So just your antennas should go up when you see these noun, verb, noun sentences involving entities, because they almost always indicate a relationship. But you got to be careful, because here, stocks that pay dividends, if you're just doing it blindly, you may say, okay, seems like dividends is a entity and stocks is an entity. So pay must be a relationship between stocks and dividends. But in fact, this is where you just, ER diagrams take some time to kind of get things right. And you realize, no, dividend is really an attribute of a stock, and it's not an entity in itself. It's not something kind of physical in any sense. Whereas a stock has an independent existence, a dividend does not. Now you could still say, well, wait a minute, you talked about strong and weak entities, and a weak entity depends on a strong entity, like a task depends on a project for its existence, or a room depends on a hotel for its existence. So just because it depends on something for its existence doesn't mean it's not an entity. And you would be right. But in this case, a dividend doesn't really have that kind of physical substance to it. It is just kind of this thing that gets paid out by a stock. So it's not really an entity. It is really better modeled as an attribute. Okay. So questions about sentence A, because that was a power-packed sentence. It had almost every single entity and relationship that we're going to use in our final result. And there's everything else, B through J, is pretty much an elaboration of what was said in A. So usually those first couple sentences are really jam-packed with information, and then the remaining bullet points are kind of elaborations that gives you more information about things. Okay, so in that case, so far we've identified 3 relationships, it seems, between a office and investment advisors, between advisors and investors, and between investors and stocks. Now, B gives us one more relationship. It says an office is managed by one of its advisors. So this again is a noun, verb, noun sentence. Office and advisors have already been identified as entities. So it very much looks like B is giving us another relationship where an advisor manages an office. And not only is it giving us a relationship, but one thing we care about with relationships is multiplicity. Okay, the number of times an entity is instances of an entity in a relationship. And we're saying an office is managed by one of its advisors. Essentially, what we're saying here is that a office, when we show this in the entity relationship diagram, and we have an arrow, so an advisor manages an office, it is managed by exactly one advisor, one and exactly one. So not only is B telling us about a relationship, it's also giving us multiplicity. Now, it's not telling us how many offices may be managed by an advisor. It's only telling us that an office is managed by one of its advisors. So it's a minimum of 1 and a maximum of 1. Now, C is saying an investor has a name, a unique investor number, a single investment advisor, and 0 or more stocks, and owns 0 or more stocks. So we already got the fact from A that an investor has an advisor and that they own stocks. But this is giving us some information about multiplicity. So we know that an investor in the relationship with an advisor. So if we start actually creating a diagram, let's start actually roughing out this diagram. That may help matters. So we know right now that we have to get rid of some of this stuff so it doesn't. So what we know so far is that we have offices. So that's an entity. And we know that we have advisors. And we know that we have investors. And we know that we have stocks. And we know that an office has advisors. We know that advisors advise investors. We know that investors own stocks. I'm drawing arrows. You might not be able to draw them yet. That's okay. We'll figure that one out. And we know that also from B that an advisor manages So this comes from B. Offices employ advisors. That comes from A. Investors own stock. That comes from A. Also from B, we know that a office is managed by exactly one advisor. Now in C, we learn that so this information came from B. In C, we are learning that first of all, investor has a name and a unique investor number. Those are attributes. Okay, they're not describing a relationship. It's just these are descriptive attributes. Okay, so the name is a descriptive attribute. Actually, the investor number is a key. And then we have a single investment advisor. So we know kind of in the relation for a investor that they're going to have a pointer to an investment advisor. So they have a single investment advisor and they own 0 or more stocks. So these two sentences, this one, or phrases, this one and this one, are giving us multiplicity information. So we know that they have a single investment advisor. So an investor has exactly one advisor. So that's coming from C. And they own 0 to many stocks. This also coming from C. So that gives us some multiplicity information. Okay, so now coming back, we have kind of dealt with C. So we'll move on to D, where we have each individual's holding of a stock contains information about the stock's ticker symbol. So ticker symbols are unique symbols that identify stocks when you place an order. So they are, in fact, a key. The stock's name, that's an attribute. The number of shares owned by the investor and the dividend per share of the stock. So this is all descriptive information. Now, the question becomes, what is a holding of a stock Is it a verb saying that it is another relationship between a investor or a stock? Or is it part of the owns relationship? And it turns out that what this is doing is it's actually giving us information about the owns relationship. So this owns relationship actually has some attributes associated with it. Okay, so it has, it's going to have information about the ticker symbol, stock's name. It's going to have the investor's ID, the number of shares, and the dividend. Now, if we go here, I'm not a stickler for you showing me this in the ER diagrams. I don't need to see the attributes. But basically, if you did show it, you would have now here a dotted line and nothing here because it's a relationship, and you would have things like the number of shares, let's see what else, number of shares, stock's name. You might think, okay, stock's name, ticker. So you might think, okay, the ticker symbol, the stock's name, the stock's dividend. Now, I'm going to show you in a moment that not all of these attributes need to be explicitly represented in this relationship, that you can find this information elsewhere. But for the time being, if you're creating a rough draft, which is often what you do, you might say, okay, these look like they're all part of the attributes for the owns relationship. So right here, D is actually giving us information about the owns relationship. Each investor's holding is equivalent to investor owning a stock. Okay, so this is where some of you would try to create an entity for holding, and it's not what you want. It is part of the owns relationship. Okay, so now moving on to E, we have an investment advisor has a name, a unique investment number, and then, so name and investment number are attributes, but one or more investments that the advisor services is giving us multiplicity information about the investor advisor relationship. And explicitly, it is saying that an investor services one or more advisors. So if we go back here, we now can say that, okay, an advisor services, so we might say services or advises, either is fine, services. Remember, this one came out of A, but the multiplicity is coming out of E. Okay, so coming back here, we see also that an office to which the advisor belongs. So this is also giving us multiplicity information about the office advisor relationship. Namely, it didn't say offices, so we are to assume when you see something like this, where it's a singular, that essentially it is one and exactly one office to which the advisor belongs. So here, you would write an advisor belongs to exactly one office. Now, you can write it as either 1.1 like that, or it's acceptable when you have a one-to-one relationship to just write it as 1. And so if you just write 1, what that implies is it is a one-to-one relationship. Okay, and that if you write 1, it tends to make your diagrams a little less cluttered. But I accept either one. In fact, my solutions will use 1.1 because it was only later that I found out that you could just write it like that, that was a common convention. Okay, so this is also, this one-to-one relationship is coming from E. Okay, so now we've exhausted E, we can move to F. An office has an office number and an address. So that's an office number and an address. That's not giving us anything other than descriptive attributes or attributes for an office. The office number is actually going to be a key. The address is going to be a descriptive attribute. So that's nice, but it doesn't really give us a whole lot of information about the ER diagram because, again, I'm not asking you to put the attributes into the ER diagram. It's just going to clutter it up too much. Okay, so then we move on to G. An advisor is associated with only one office. So that is actually just reinforcing this statement here, an office to which the advisor belongs. I'd already inferred that when it said an office to which the advisor belongs, that an advisor could belong to only one office, but G makes that assumption absolutely explicit, that it's exactly one office participates in this relationship. So moving on to H. We see that an office may have multiple advisors. So this is now giving us information about the office advisor relationship and explicitly the multiplicity. So we know that now an office may have multiple advisors. So it doesn't say whether it's 0 many or 1 to many. I'm going to assume 1 to many here. So I'm going to write an offices employ 1 to many advisors. So this is coming from, I believe, H, that it's 1 to many. I know this might be a little hard to read. This was 1 and an asterisk here. Okay, so moving back. We now know that the dividend per share is determined by the stock. Okay, we already had known that a stock pays a dividend. But this is saying all holdings of IBM pay the same dividend. This is important information because what it means is we don't have to hold that dividend information in the owns relationship. If each person was getting a different dividend, then we would have to hold that information in the owns relationship. But because this is saying all holdings pay the same dividend, it means we can put the dividend with the stock and we no longer have to put the dividend with the relationship. So in fact, we don't need to have the stock's dividend here. We also don't need to have the stock's name. Can anyone tell me why we don't need to store the stock's name explicitly in each holding? Why that might not be necessary?
We already know the ticker.
Very good. So you already know the ticker, so you can use the ticker to find the stock's name in stocks. So we want to avoid storing redundant information. Since we already have the ticker, we can use that as a foreign key into stocks, and that will give us the stock's name. So we can get rid of stock's name. And then the final thing we can get rid of, counterintuitively, is ticker. The only reason I get rid of ticker here, and I wouldn't penalize you for including it, is that in general, you don't put foreign keys into as attributes because the foreign key is implied by the relationship. So if you put ticker in here, I wouldn't be unhappy, wouldn't take off points, but technically you don't put foreign keys as attributes in your ER diagrams because the foreign key is implied by the relationship. So in fact, the only thing you absolutely would need as an attribute would be the number of shares. Now, in fact, the relation would also contain the ticker and the investor number, but you don't necessarily, as I said, you don't include foreign keys typically in your ER diagrams. Okay, so now we get to J. We have when a stock gets purchased or sold by an investor, we record the stock's ticker symbol, the transaction price, the date, the number of shares purchased or sold, the investor who purchased or sold the stock, and the advisor who conducted the transaction for the investor. Wow, what a mouthful. Okay, so let's try to dig in and see what's going on here. When a stock gets purchased or sold by an investor, this sounds like a noun, verb, noun relationship. So this is sounding like noun, verb, noun. And with stock and investor, we already know our entities. So this looks like some kind of relationship between a stock and an investor. And it looks like this purchase, it might be a purchase relationship. It involves the stock's ticker symbol, the price, the date, the number of shares purchased, the investor who purchased and sold the stock. So if we just look here, whoops, let's just get rid of this for a moment. And so if we just look from right here, it looks like it's giving us attributes for this relationship. So the stock's ticker symbol and the investor who purchased, sold the stock are essentially foreign keys. The transaction price, the date, and the number of shares purchased all are attributes of the relationship. So right now it kind of looks like we're dealing with something that looks like a stock or an investor purchases stock, and it looks like this thing has some attributes associated with it, this relationship that includes the date, number of shares, and price. And of course, if you, like I said, I'm not going to penalize you for putting investor number and ticker here, but they're really foreign keys. So far, it looks like a binary relationship, but something changes because we end by saying we record the stock's ticker, blah, 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 and the advisor who conducted the transaction for the investor. This is all recorded in one place. So it turns out that this is a three-way relationship. a advisor purchases the stock on behalf of the investor. So it is actually a three-way relationship between an advisor, the stock, and the advisor, stock, and investor. Okay, it is not what you want to, okay, so the way we should show this, gotta get rid of, whoops. So our final thing, it's getting cluttered unfortunately, but we have this purchases. So an advisor purchases a stock for an investor, and then you have a set of attributes that include the date, number of shares, and price. So that's a three-way relationship. What you do not want to write, okay, what would be bad is if you wrote investor purchases stock, and somehow you thought also that an advisor buys stock because, or conducts transaction it'd be wrong to write it this way. You might think, oh, I'm going to write it this way because in J here, I have stock gets purchased by an investor, and I have advisor who conducted transaction for the investor. Actually, in this case, you might end up, I'm sorry, instead of writing it that way, you might think advisor conducts transaction for an investor, and you'd write it that way and it would be wrong. It would be misleading because that's not what is, it's not two binary relationships, but instead it is one three-way relationship where an advisor purchases stock for an investor. So that is what is going on here. So again, it's a mouthful, but you're going to have to sometimes try to not take sentences literally, like here, stock gets purchased by an investor, advisor conducts transaction for the investor, but realize that actually these two sentences are describing the same relationship. And that's one of the hardest things to get used to when you're new to ER diagrams. But the fact that this is all being described in one sentence or one bullet point points to the fact that it might be all part of the same relationship. I'll show you something else that might get you to the fact that it is a three-way relationship in a moment. But before I do that, I'm going to show you what we have so far. So this is just a cleaned up version of what you saw before. Now, it was missing the multiplicities for the transaction relationship, and it was also missing a multiplicity over here for advisor. If you look at what I have, you'll see there's no I'm missing a multiplicity here. There's a missing multiplicity. I don't have any multiplicities on my edges for the purchases relationship. I don't have anything here, so I'd have to fill this in as well. So these are things that we need to kind of go back and look at the write-up and see if did they give us some information that we just missed. So let's go back and see if there's anything that we can divine that we might have missed. And I don't think there is. I don't think in it we said an investment advisor has a name, an advisor number, one or more investors. It didn't say that, and exactly 0 or 1 offices that a advisor manages. So there's no information here about the office an investor or an advisor might manage. Nothing here about it. So we're going to just have to make an assumption. My assumption would be that an advisor could manage 0 or 1 offices, that normally they wouldn't manage multiple offices. And of course, most advisors don't manage any office. We don't really say with a stock, the only thing we're giving information about stock is the dividend per share is determined by the stock. But we do say all holdings of IBM pay the same dividend. So there's a little bit of a inference there that stocks may be held by multiple individuals. And of course, you probably should be able to figure out that stocks can be held by multiple individuals. So on the solution, we say that a stock may be owned by 1 or more investors. We're not going to probably have the stock in our database if no investor owns it. So we're going to assume that at least 1 investor owns it and that potentially many investors own it. So that leaves us with trying to get the multiplicity for the transacts or purchases relationship. Now, the reason transacts might be better is because it might be a purchase and it might be a sale. So it's actually not necessarily a purchase. So transacts is a bit better, more generic, encompassing the fact that it could be a purchase, it could be a sale, so on and so forth. So,
Doctor,
yes, go ahead.
oh, sorry. This diagram that we're seeing, where is that located? Is it in files or is it on the website?
It's on the website. If you go to Investment Firm Solution, right here, can you see that?
Yes. Okay. Yeah, I got it.
Then, and scroll down to the bottom. You'll see it.
Thank you.
You're welcome. Okay, so we need to come up with multiplicities here. So first of all, we kind of think about the fact that if we have, so this is going to be represented as holdings. In fact, let me, before I get to the multiplicity, it might help, I think it will help, if I pull back and do a couple other things. First of all, notice here I did say that dividend paying stocks are a sub-entity of stock. I would certainly not hold you to that on a test or a homework assignment, but I was just showing you that this is one example where you might say that a dividend paying stock is a subtype of a stock, because not all stocks pay dividends. So you might very well just have dividend be an attribute of a stock and it's allowed to be null. And if it's null, that means it doesn't pay a dividend. That's perfectly fine. Or another way to do it is to define 2 entities, a stock and a dividend paying stock, the dividend paying stock would have a ticker indicating the stock that pays the dividend and the dividend amount. And it might have like how often it pays out, monthly, quarterly, etc. So it might have some additional information too, or you just might have it in the stock itself, not have this, and it just include dividend as one of the attributes. But if you're going to include multiple pieces of information, and you very well might, you might have, for example, the last date on which it was paid or the next date on which it would be paid, then it would be more likely for you to separate that out into a separate relation and think of it as a separate entity. So the more attributes that you would typically associate with that subtype entity, the more likely you are to actually explicitly or physically model it in the database as a separate relation. Okay, so let's take a look at what I came up with. So it says define the entities and attributes for each entity and also define any relationships that have attributes. So this is what I came up with. So we knew that an office had an office number, an address, and a manager. So an office is managed by one of its advisors. An office has an office number and an address. So it needs this information. An investor, we learned, and let's see, an investor has a name, a unique investor number, a single investment advisor. So here, investor number, name, investment advisor. We know that they own one or more stocks, but that is going to be taken care of in holdings. So that's going to be a separate relationship between the advisor and, I'm sorry, between the investor and the stock. So then stock information, I chose here just to have a single entity for stock with a ticker, the name, and the dividend. And then there were two relationships that you may remember from my whiteboard. There was this owns relationship, and there was this transacts or purchases relationship. So in my solution, we have a stock transaction with an ID, ticker, investor number, advisor number. So the three foreign keys, then price, date, quantity, and type. So type is sale or purchase. I didn't have that in as an attribute, but type, is it a sale? Is it a purchase? Maybe it's a transfer, some other things. And then holdings, this is what this is the owns relationship. So we give the ticker, the investor number, and the quantity. And this is where, when you've written down this kind of information, sometimes it helps clarify things for you. So here it says when a stock gets purchased, you kind of record all this information. And so you put all that information into this entity, you put all that information into this particular entity. And now when you look at that, you may say, wait a minute, this thing has three foreign keys. It has a ticker, an investment number, and an advisor number. Perhaps that's indicative of the fact that it is a relationship and not an entity. The fact that it's bristling with all these foreign keys often means that it is a relationship. So that might tip you off when you're, that's what I mean is sometimes you go back and forth between creating relations that you're going to store physically on the database and your ER diagram. And sometimes you can gain clarity by looking at one or the other, and that will allow you to refine the other one. So here you probably see that, you put all this information into a stock transaction, and since you have 3 foreign keys, it's strongly indicative of the fact that it's probably a relationship. Okay, and the same thing with holding. So part D, it said each investor's holding of a stock contains, and you end up putting the ticker, the investor number, the quantity. And now we, originally we put in some additional information. We had dividend, stock's price. So you might include that originally and then realize, oh, wait a minute, by just following the ticker, I can figure out what the name and the dividend of the stock are, so you could get rid of it from holdings. But you might also say, okay, there's no real unique identifying information here, but there are 2 foreign keys. So it looks like this might be a relationship. It doesn't seem to have its own unique, it doesn't exist independently by itself. It exists because a investor actually purchases a stock. Okay. So then the final thing is we ask for the primary and foreign keys for each entity. So for an office, the office number is the primary key. For an investor, the investor number is the primary key. For the advisor is the primary key. And for stock info, the ticker is the primary keys. Those are easier. For the holdings and stock transaction, most likely you would just say ticker and investment number. There's really no good reason to create a artificial key for a holding. The reason is you don't really need to use that a lot in a join, but it turns out I could for stock transaction. I know I didn't have, I put in a transaction ID. If I didn't do that, it would get kind of gnarly, because we know that an advisor purchases a stock for an investor, but they may purchase or sell that stock on multiple occasions. So that doesn't give us a unique key. So then we might say, okay, we'll add date to that. But there are active traders that will buy and sell on the same day. And sometimes also it turns out that even for the same order, it turns out it gets subdivided into suborders that are filled at slightly different prices. So it turns out that even if I have ticker, investor number, advisor number, and date, that's not going to be unique. I've had, they might purchase or sell at the same price on the same day. So it turns out that even if I add quantity and type, just out of bad luck, none of that may make a stock transaction unique. So it turns out that the best thing to do is to add a transaction ID, because in fact, it is the only way I can guarantee uniqueness. As I said, even if I include all attributes in the primary key, the transaction still, for bad luck, may not be unique. I may have an investor purchase the same stock on the same day, same quantity at the same price, and that would make two identical entries. And hence I need separate transaction IDs for them. So I would probably create an artificial key for stock transaction, whereas there's really no good reason to create an artificial key for holdings. And finally, we need foreign keys. So if we're looking here for office, the manager is a foreign key because it's an advisor number. So that's why I said it's advisor number and advisor. For an investor, it has an advisor number. That's a foreign key into advisor. For an advisor belongs to an office, so it has a foreign key for office. A stock, if we look at a stock, it has a ticker, a name, and a dividend, so no foreign keys there. Then a holdings, the ticker and investment number are foreign keys into the stock and owner or investor relations. And for a stock transaction, the ticker, investor number, and advisor are foreign keys to the three entities involved in that relationship. So with our relationships, the holdings and stock transactions, the foreign keys are pointers to each of the entities involved in that relationship. Okay. So then we have our one here. Now, in terms of directing arrows, at the beginning I said you may be a little unclear how to direct the arrows. Remember, my rules were for one-to-many relationships, it goes from the one to the many. So an advisor advises one-to-many investors, so it goes that way. An investor owns zero-to-many stocks. Now, this is a many-many, and it can go either way, but I want an action verb, and it's more actiony to say an investor owns stock than to say a stock is owned by investors. That's passive. The to be verb there is. So it's better to go that way. The transactions, that is undirected as far as the edges. Remember that diamond-shaped relationships are undirected. That leaves us with here our one-to-one, here's another one-to-many. An office has one-to-many advisors, so that's pointed there. So we have one-to-one relationship, and it's right there between advisor and office. And I said in these cases, the arrow should point to the entity that contains the foreign key. So in this case, we look up here, it is office that contains the foreign key. Therefore, we direct the edge into office and say advisor manages an office. Which leaves us with one thing to do. I still haven't told you how I came up with these multiplicities on these edges. And this is where having come up with the stock transaction relation here helps, because now we can start to concretely try to think of stock transactions. So coming down to here, okay, we can think of, okay, we have a transaction. And the first thing we want to do is figure out how many advisors can be involved in the purchase of a stock by an investor. So if we down here have some stock like IBM, and we have some investor like BVZ, then the question is, how many advisors may have executed this transaction for me. And what we need to know is actually, can there be multiple instances in this relationship could we, for example, have advisor A10, and could there at some time be another purchase of IBM by me and some other advisor like A20? And the answer is, in general, yes, that maybe you're shuffled between advisors. You, over time, the advisor you were with may retire or leave, or they may be on vacation and another advisor fills in for them. So it is quite possible that in this transaction relation, there will be 2 or more instances of IBM and BVZ with different advisors, and hence it becomes 0 to many. Or you might say it has to be 1 to many because it would only be in here if there was a transaction. So you might also argue that it has to be 1 to many. I wouldn't go against you on that one. Okay, then for the next one, we want to determine how many stocks an advisor may purchase for an investor. And I think even without trying to figure that one out, it should be obvious that an advisor may purchase 0 to many stocks on behalf of one investor. Okay, a new investor, they may not have yet bought any stocks for that investor, but they also over time may purchase many stocks for that investor. So that's kind of an easy one. And then for a particular stock and an advisor, so we have an advisor like, say, A10 and IBM. The question is, can A10 purchase IBM? How many investors can A10 purchase IBM for? And the answer is probably many. Maybe 0, maybe none of their investors have purchased IBM, but I may sell, as an investment advisor, I may sell IBM to client A, to client B, to client C. So an advisor is allowed to sell a stock to 0 or arbitrarily many investors. So it would be 0 to many. So I think 2 of these are natural. I think it's natural to say that an advisor purchases 0 to many stocks on behalf of an investor. So this one I think is somewhat natural. I think it's also somewhat natural to say that an advisor may purchase a stock for many investors. So this is somewhat natural. This is the one that's a little hard. The fact that multiple advisors may purchase the stock for an investor may or may not be so clear or obvious. Okay, I know I've covered a lot, but hopefully this will give you some idea of how you want to tackle a problem like this on an exam or on the homework assignment. Any questions about any of this?
Dr. VZ?
Mm-hmm.
Not so much about the details, but the one thing that kind of strikes me a little bit is if we're given a problem like this, but we're not familiar with how the stock market works, you know, the relationship between investors and stocks and just the subject matter, won't that make it kind of difficult to form these relationships? I mean, we have all this information, but if we don't quite get how those things are related.
You are right, but that will happen to you in the real world too. So in the real world, you would go and ask people for clarification. In this world, you'll get on Piazza and ask me for clarification.
Okay. And
okay,
if it was,
you are going to be faced with that in the real world. You're going to go into firms and businesses, and you're not going to be completely familiar with their business model or how that industry operates.
Right. Yeah. No, definitely. And I would definitely be asking
So
questions.
yeah, don't hesitate to ask questions if you don't understand the workings of things.
Okay. I'm assuming that this type of question like this will be on the exam. And will the subject matter be, you know what I mean? Like, you know, everybody kind of knows about it kind of thing. Is it going to be
Well, I'll
something
give
like
you
that?
a big hint for the exam. It's going to be, the example in the exam is going to be, you are trying to design a vaccine appointment site. Because I'm so ticked off about the fact that it took them so long to develop appointment sites for getting vaccines. And it turned out, I wrote it down, you can figure it makes a really good exam problem. So I will tell you right off the top that what you will be dealing with on the exam is you'll be creating an ER diagram for a vaccine appointment site. Now, I'm not going to give you further details than that right now, but that's what the exam question is going to be about.
Okay. Oh, that's great. I appreciate that.
You're welcome.
Thank you.
Yep. So other questions.
For problems where context does come into play and we were to incorrectly assume something, is partial credit at least generous with that? You know, if it's clear that we were just under the misunderstanding of the concept.
You're probably going to have to argue for the partial credit with me, because the TA is also not as experienced with the ER diagrams. What I generally don't get to, what I definitely don't get overwrought about is the 0 or 1. That's a pretty tough one to figure out. The other ones, though, if you're unclear about something, I often do want you to post something to Piazza, because in the real world, you can't just go off making a whole bunch of assumptions. Now, you may think you understand it well, and if that's the case, I understand. And if you come back and argue, I really felt like I understood it well for this reason, I'll accept it. But if it turns out that you were kind of fuzzy on it and you just were too timid to post something to Piazza, I'm not going to be happy about that. That's where you just gotta, you're going to have to do it in the real world. If you're fuzzy about something, you gotta clarify.
So we should write our assumptions down. Say we're doing the homework or the test and we're seeing this and we interpret it a certain way. We should write our assumption down right there.
Yes, what I'm trying to do is see what the, so the problem is for a video rental company. So while, I mean, if the problem is, if you're writing down assumptions for the homework assignment, I probably would prefer that you explicitly, before you submit it, that you actually post to Piazza. If you want, you can make it a private post and say, are these legitimate assumptions?
Okay.
On an exam, I understand where you may have to just write them down, because I can't deal with everyone telling me what their assumptions are. But on the homework, I would definitely, if you think you're having to make an assumption, I would definitely prefer that you just privately post Piazza to me and say, hey, these are assumptions I am made, good or bad.
Would it be okay to make it public just in case, you know, so you don't get a lot of the same
actually,
questions?
yes. The answer is yes, because now assumptions that I don't want you to put up there is I'm assuming this is a three-way relationship among A, B, and C, because that's like a big giveaway. That's the one assumption I don't want you posting. So if you have a question about relationships, I'd rather you make that private, because that one of the biggest things is figuring out what the relationships are. But if you're struggling with multiplicities, definitely a public post is nice.
That makes sense.
Okay. Other questions? Y'all are free to go, by the way. At this point, it's just some question and answer about homework and ER diagrams. So.
I have a question.
Mm-hmm.
Okay, so I don't know if this has been asked yet. It may have been, but so for turning in the homework, do you want us to have like separate like files like we did with the SQL files, like 1.docx, 2.docx?
Actually, Bhaskar just posted a pretty detailed Piazza post about that. Let me bring up Piazza for a moment. Hopefully this won't force a sign in. There we go. Not here. Here it is. Bhaskar was saying this, and in the future, take a look at that. I'm not going to read it out to you, but on Piazza, he just posted something about what he wants to see in the future.
Okay.
Can you see this? It says,
yeah.
Place them zipped in a single file. He said you don't even need to zip the files after adding them to a folder. So I think what he's saying is he would prefer you add everything to one folder, put them in separate files, and then zip. Or is that not answering the question you have?
For homework 3, the write-up does say everything should be in one single PDF file.
Oh, okay.
Yeah, because for homework 3, for homework 3, there is no execution stuff going on.
Yeah, that's why I was asking, because it was like we're supposed to prepare everything in a word processor. So I was just wondering if that changed.
Having it all in one document. Actually, for homework 3, he'd probably be happy if it was all in one document. But I totally understand if you'd rather do the relational algebra and relational queries by hand rather than trying to, hunt and peck through an equation editor. Or try to use LaTeX. So I completely understand if like you use LaTeX to answer the relational algebra and relational calculus questions, and then you use Word or PowerPoint or some other diagram creating thing to create the other ones, and you put them in 2 different PDF files, that's fine. You may have to, I guess what I'm saying is I'd be flexible there on how you create your PDFs, because I can see that how you create your solutions for your relational algebra and relational calculus queries you may want to use a different editor or piece of software for them than you do for the ER diagrams.
Okay, thank you.
You're welcome. Other questions? Go ahead.
Oh, I was looking, and I assume even though it's one word processing document, he still wants it zipped up so it'll match his scripts. Well, I guess there's no script.
No, there's no script here. Yeah, this isn't, don't worry about script. You don't need to zip it. Believe me, you don't need to zip it. I guess he might prefer if you have multiple files that you zip it, simply because then he only has to do one download rather than multiple downloads. So
that makes sense. But if it's already just one
multiple PDF files, zip them up so that he can do it with a single download command. Other questions?
Actually, I think on Canvas, if you do a download all, it zips up whatever files are for that student anyway in a zip. So you would have a zip inside of a zip if you zipped it and submitted it.
Oh, interesting. But okay.
I'm dealing with that right now. So yeah, that's what I've seen.
So actually, you'd prefer, if you're working on Canvas, you'd prefer that they not be zipped, since Canvas actually zips them for you.
Well, if it was scripted, I still actually, that's a really good question. We're telling everybody to tar it up because that's the way it's script. We were building our scripts, and we use the zip because it puts their name in it. So that really makes it good for scripting, because then we throw that into the file. We have their score that pops out at the end after the script. But really, I guess there's no need to really zip it up if you do it that way. But oh well.
So I'll just say zip it up. If you have multiple files, probably makes it easier for the TA. Okay. Other questions?
So back to the content for a second. I know we haven't talked much about implementation yet, but is it fair to say that both entities and relationships with attributes would be implemented as tables each
Yeah,
themselves?
exactly. So basically, if you
Okay.
look at my solution, pretty much everything that you see here. So basically, any entity will be a table. Any relationship that has attributes will be a table. And then what you're not seeing here is any multi-valued attribute has to be put in a separate table, like phone numbers.
Okay.
But yeah, so basically the rule is all entities map to a table, all relationships with attributes map to a table, and any multi-valued attribute will map to a table.
Okay. Also, holdings, would that be implemented as a view since it sort of relies on stock transaction as an aggregate, or would you want to have
No, so
both of those as
actually, I
tables?
see what you're saying, that you technically could come up with an investor's holding as, that's an excellent point, that technically the quantity could be computed as a derived attribute. I'd never thought about that. But I think in practice, this is one time where they would probably cache it in effect and say that it's part of this separate relationship. That's a really nice point.
Okay, that makes sense. Thank you.
There are times when you actually do that for efficiency. I'm actually doing that in a database right now. I'm keeping a redundant string in two different places just because the efficiency dictates that even though I have to always remember to update it in two different places, it's just a whole lot better for speed, if I hold it in two different places.
That's interesting.
Yeah.
Would you say that if you can cache some kind of result like that, that you know you're going to need like the quantity instead of just, every once in a while you want to look at it, it's always better to cache.
Yes.
Would you say, even if it's dependent?
Yes, especially because this is something that doesn't change often. Like, I don't know, I guess with day trading, it could change frequently, but it's not that hard of a number to remember to update. It's natural that you would update a holding. So it's not hard to remember to do. So yes, for something like this, it would definitely say you would tend to cache it. Whereas if you're talking about the number of staff in an office, you probably wouldn't, because it's just so easy to do a group by an account.
Right. Yeah. And I don't know if you'd ever really need that often, the count.
Right, but I know what you're saying. I'm just saying there are certain, I guess it's also like, trying to think, you might have a view that gives you, let's say, the number of rooms that are occupied on each day for each hotel. And that's something you probably also wouldn't cache. You'd probably just generate it as a view. I guess it comes down to, you just have to think about how easy or hard it is to create a view for it, how efficient it is. There's no right or wrong answer. Having said that,
I don't know.
We're at the insight that holdings isn't really necessary because quantity is a derived attribute. That was a very good insight.
Of the quantity and what we're talking actually brings up another question, kind of a weird
from stock transaction. That technically you could compute quantity from stock transaction. Just add up all the purchases and subtract all of the deductions, and it turns out that You could do something like use a minus sign when you did sales. If you were cute, you might put a minus sign rather than a plus sign for the number of shares. Or I think SQL actually does possibly have simple if then else statements. There are things you could probably do that would allow you to, in an SQL statement, compute the quantity from the transactions if you were clever.
Does anybody ever create a table? Like, say we have this relationship from this example and it's all built out like we're looking at it now. But then every once in a while, someone wants to know like these statistics of the databases. Does anyone ever, but you might want to know it more than just rarely. Does anybody ever create a table that's a join and just join all the tables together and just keep track, like make attributes that are derived and just keep it all in a table?
Yeah, that's
just so you can, if you ever want to do it again, just go to the table.
Yeah, they just create a view for it. That's what a view is for. A view is basically one use of a view is for a big join table like that. So you don't want to, and then you can specify whether it's cached or not. Remember when we talked about views? Views could either be materialized or they could be resolved. So
okay, I don't think MySQL does.
Pardon?
MySQL doesn't do materialize, correct?
I don't know. I would have to check.
I think I read somewhere. That's why I said table, because that sounds like something you want to keep in memory. And views, at least from a MySQL standpoint that I read, are temporary. And I guess, I don't know.
I suppose you could do that, but the problem is you would have to maintain it yourself. As far as I know, MySQL would not give you any way to have that table then automatically maintained. A view will automatically maintain that information for you by automatically updating. Now, the other thing is MySQL has something called triggers, and I've not gotten ever into triggers. So it's possible that I don't know anything about triggers, but triggers might give you the ability to do what you just talked about. Have a table that contains all that information and then associate a trigger with the table so that if a underlying relation changed, you would be notified and you could do some computation to update the table.
Okay.
But again,
trigger,
I'm not familiar with
capture.
MySQL triggers. I've never used them.
Or
Okay.
you might just want to use like Microsoft SQL or something that does support cache tables at that point.
Yeah, so you might want to
Cache
use a
tables.
real, I'm sorry, I shouldn't say real SQL server, but one that's not public domain.
Yeah. Okay.
That's the other option is to
That makes
pump
sense, yeah.
up the money.
Go with something that someone already made it for. Yeah.
There you go. Okay, yeah,
All right.
I actually have to get to another class, so I am going
Yeah, thank you for staying.
terminate.
Yeah, thank you.
Wish y'all a happy weekend.
You too.
Yeah, you
Thanks,
too.
Doctor.
Bye.
Thanks, Zen.
See y'all later.